Hey, we have here another integral from the UNSW Integration Bee from 2019, problem number 4. And this is a little unusual. They've given us the integral from 0 to infinity, x to the n, e to the minus x dx. I can't remember, but I believe they said n is a positive integer. And something you might notice here is actually this isn't exactly the form of the gamma function. So what we have here is actually the gamma function of n plus 1, and then we could write that as a factorial. I think what they were intending from this problem is to have us show it. I think what I'm going to do is use integration by parts and get the same result, kind of the long way, even though it's something that you could actually see just by looking at it. Okay, so integration by parts, we're going to set it up tabular integration, and that's going to be good because we're going to have to apply this many times or multiple times. So we got two columns, one to differentiate, one to integrate. What I'm going to do is differentiate our x to the n, because I think that's going to be nice that way, and then integrate e to the minus x. And then we'll just integrate this a whole bunch of times. So I'm just going to pull that minus out, and the sign here is going to switch back and forth. And then we'll differentiate here. We're going to have n x n minus 1, n minus 1, x n minus 2. And we could actually just go on and on with this forever. So I better stop at some point. Okay, what I did is, just because this is sort of an infinite integration by parts, I just kind of did some dots here to show that we're doing however many that we needed right here to get to eventually our power is going to reduce to 1 and then to 0, and we just have an n factorial here. And then the thing to notice for our solution is just going to be all these diagonals, okay? And then one thing that's a little important, notice that no matter how we did this, it's always negative, right? Because here we have a positive times a negative, negative times a positive. So the way the signs are interchanging, every term's negative. And then rather than, we're not going to evaluate this a million times, but what we can do is, let's just look at any one example, right? So let's just look at this first one. In our solution, we're evaluating minus x to the n, e to the minus x from 0 to infinity. Well, when you plug infinity in here, the exponential grows much faster, and it's going to be in the denominator. So we have a 0. And then for the second part, for the 0, when you plug a 0 in for x, you're just going to have 0. So this whole thing is 0. But you'll notice that's going to happen for each of these diagonals. It's the same situation with an exponential, where the infinite terms are going to go to 0, and then you have an x term where it goes to 0 as well. That's true even for this last one. Just real quick, right? If we have, for this one, you'll notice the same exact thing is happening. The infinity is still going to 0, and the x is still going to 0. So it turns out we can basically ignore all of this and just deal with this last integral here. Okay, so what we're really dealing with is the integral. Now here we have a positive, minus minus positive. We can bring the n factorial up front, and we're actually just integrating e to the minus x. So then let's evaluate that real quick. The integral, that's just going to be minus e minus x. Don't forget the n factorial. We evaluate this from 0 to infinity. And now it's kind of similar to this, but just a little bit different. When we plug our infinity in, again, the exponential is growing much faster, and it's in the denominator. So this term here, e to the minus infinity, essentially is going to 0. Now for the second part, we plug a 0 in for e to the minus x. E to the 0 is 1. So we just have this minus n factorial, okay? But minus times minus gives us positive n factorial. Then just going back real quick, I mentioned our definition of the gamma function. This would be the same thing as gamma of n plus 1. But by that definition, gamma of n plus 1 is actually the same thing as n factorial. That's it, kind of like it. We don't usually get to do a general case like this, so I enjoyed it. Thanks for watching. Have a good day.